Hello everyone, this is a very beautiful logarithmic equation and here we are to look for the value of x, which is the unknown. So we will solve together and say solution. You can closely see that they are of different base. So we're going to change it to the same base, either base 4 to base 2 or base 2 to base 4. Whichever way is fine. We arrive at the same answer. So but then we're having log squared x to base 4. And this can also be written as log x base 4 to the power of 2. So if we agree on this, our next line will therefore become log x to base 4 to the power of 2 minus log x base 2 equal to 4. And we are fine. So in the next line, we are going to employ the change of base law that says log a base b is equal to log a base c all over log b base c. So if this is true, our equation will become log x base 2 all over log 4 base 2 all to the power of 2 minus log x base 2 equals to 4. And here, 4 can be written as 2 to the power of 2, so that our equation will become log x to base 2 to the power of 2 all over log 2 to the power of 2 base 2. Remember, it is squared also. Here is minus log x to base 2, which is all equal to 4. So the next line will be log x base 2 to the power of 2 all over. Here the power will come down to be 2 log 2 base 2 to the power of 2 minus log x base 2, and this is equal to 4. But log a to base a is equal to 1, so that log 2 to base 2 will be equal to 1. And our next line, it will be log x to base 2 to the power of 2 all over 2 times log 2 to base 2 is 1. This to the power of 2 minus log x to base 2, which is equal to 1. And the next line will therefore become 2 times 1 will be 2, and 2 to the power of 2, that is 4. And this becomes log x to base 2 to the power of 2 all over 4, which is the denominator, minus log x to base 2 equals to 4. Here we have log s to base 2 and log x to base 2. So we can say that let k equals to log x to base 2. Here our equation will become k squared over 4 minus k equals to 4. So we can multiply through by 4 so that we can eliminate this fraction. And if we do that, it will become k squared minus 4k equal to 16. So this is a typical quadratic equation, and we're going to use the completely the squared method in solving this, which allows us to add the square of the coefficient of k to both sides. The coefficient of k here is minus 4, and half of minus 4 is minus 2. That is k squared minus 4k plus minus 2 squared is equal to 16 plus minus 2 squared. Minus 2 is gotten from minus 4 over 2, which is a half the coefficient of k. Eventually, this gives us minus 2, and we are fine. So the left-hand side of this equation is a perfect square. That means we can write as k squared minus 2 squared equal to 16 minus 2. Here is plus. So this means k minus 2 all squared is equal to 16 plus 4. Since the k is the unknown, we have the responsibility of eliminating the square. So what we do is to take the square root of both sides as k minus 2 squared is equal to plus or minus square root of 20. 20 is 16 plus 4. So here, the square root can cancel each other, which means that k minus 2 is now equal to plus or minus square root of 20. But we can split 20 to be 4 times 5, so that k minus 2 is equal to plus or minus square root of 4 times square root of 5. K minus 2 is equal to plus or minus 2 times square root of 5. And finally, k can be equal to 2 plus or minus 2 square root of 5. But recall that k was assumed to be log x base 2, so that log x base 2 is equal to 2 plus or minus 2 root 5. And this very one can be written in an index form as s is equal to 2 to the power of 2 plus or minus 2 root 5. Here, this is in the log form, and there is index form, which means that s can be equal to, you can factor out 2 here to means that 2 raised to power 2 plus 1 plus or minus square root of 5. And the next line will be s equals to 4 to the power of 1 plus or minus square root of 5. So that the values of s1 will be equals to 4 to the power of 1 plus square root of 5, and x2 will be 4 to the power of 1 minus the square root of 5. These are the two values of s. So to verify this, we have log s base 4 to the power of 2 minus log x base 2 equal to 4. So in the place of s, we put these values, which means that log 4 to power 1 plus square root of 5 base 4 to the power of 2 minus log 4 to power 1 plus square root of 5 base 2, could it be equals to 4? And this also can be written as log 4 to base 4 to the power of 1 plus square root of 5 or the power of 2 minus log 2 to the power of 2 to base 2 to the power of 1 plus square root of 5. Could it be equals to 4? But log a to power x is written as s log a. So the power comes down to multiply the log. It will therefore becomes 1 plus root 5 times log 4 base 4 to the power of 2 minus 2 times 1 plus root 5 times log 2 base 2. Could all this be equal to 4? Also, but log a base a is equal to 1, so that log 4 base 4 can be 1, and log 2 base 2 also can be 1. So that our next line will be 1 plus square root of 5 raised to power 2 minus here 2 into 1 plus square root of 5. Could this be equal to 4? Here, if we open up the bracket, just be 1 times 1 be 1 squared plus 2 times 1 times square root of 5 plus square root of 5 squared minus 2 times 1, 2, minus 2 times square root of 5 be minus 2 root 5. It is actually equal to 4. So if you simplify further, you have 1 squared to be 1 plus 2 root 5 plus here the square root will cancel off the square to be left with 5 minus 2 minus 2 root 5. Can we consider this to be equal to 4? So here, if we solve further, you see that minus 2 root 5 plus 2 root 5 can cancel out, and what is left is 1 plus 5 minus 2. Can this be equals to 4? And obviously 1 plus 5 is 6 minus 2 is equal to 4. So 4 is equal to 4. This means that the value of S satisfies the original equation